Hello, in this video we are continuing our discussion of section 8.2 on series, and in example 3 we're considering the series, which is the sum from k equals 1 to infinity of 3 over 10 to the k. We have two parts to this example. First, we're asked to write out the first four terms of the sequence of partial sums, and second, we are asked, does it seem like this series converges or diverges? If it converges, can you guess what it converges to? Now, the reason why we're only guessing here is really we're not truly evaluating the limit of the sequence of partial sums. We are going to be looking at the first few terms of the sequence, looking to see if there's a pattern. If there is a pattern, perhaps we can guess from there whether it converges or diverges. So starting off in part 1, S sub 1 is just the first term in the series, so that's 3 over 10, which is the same thing if we wanted to write it as a decimal, 0.3. S sub 2 is going to be the sum of the first two terms, so that's 3 over 10 to the first plus 3 over 10 squared, which is the same thing as 0.3 plus 0.03, which is 0.33. S sub 3 is the first three terms, 3 over 10 plus 3 over 10 squared plus 3 over 10 cubed. That's 0.3 plus 0.03 plus 0.003, which is 0.333. And S sub 4, we could add up the first four terms, or we could use the fact that we're going to take the previous term in our sequence, 0.333, plus the next term in the series, so that's 3 over 10 to the fourth. 3 over 10 to the fourth is the same thing as 0.0003, so we're going to get 0.3333. So our sequence of partial sums starts with the terms 0.3, 0.33, 0.333, 0.3333, and it does continue from there. Now, for part 2, does it seem like this series converges or diverge? So looking at the terms in our sequence of partial sums, it's pretty easy to see that the next term in our sequence is going to simply have one more 3 value on there. And so the next one after that is going to have another 3, so there's going to be 6 3s in the decimal, and then the next one will have 7 3s, and so on and so forth. So it seems like our sequence of partial sums is approaching a decimal with an infinite number of 3's on there. So we could say this is 0.3 repeating, which if we convert that to a fractional value, we know that is 1/3. So it seems like this sequence of partial sums is approaching 1/3, and if the sequence of partial sums approaches something, then that means the series does as well. So the series sum from k equals 1 to infinity of 3 over 10 to the k seems like it converges to 1/3. That would at least be a good guess. Now, this is actually true that this series converges to 1/3, and we are going to see in our next lecture why this is true. And it comes from the fact that this is called a geometric series. If you remember, oops, sorry about that. If you remember from the previous section on sequences, we had a geometric sequence which looked like r to the n. So now you could imagine a geometric series having r to the n in the terms. So, or perhaps we should write it as a k. So something like the sum from k equals 1 to infinity of r to the k. Here, the r value that we have is a 10 in the denominator, or in other words, a 1/10. And we're multiplying the whole thing by a 3. So normally, geometric series are written as a times r to the k. So the a value in the series in this example is 3. But in the next lecture on this section, we'll get into some more details on geometric series, when they converge, or for what values of a and r they converge, and then if they do converge, what they converge to. We will end up seeing a result that will make it a lot easier to figure out whether it converges or not than what we've done here with our sequence of partial sums.